Hello everyone, my name is Mark Leuis from BSED Science 3A, and in this video I am going to discuss my solutions with regards to the two problems in length contraction. So we have here our number one problem, which is an astronaut inside a spacecraft moving at 0.75 the speed of light measures the length of the ship as 250 meters. How long does it look to someone on Earth? So first, we are going to identify our given, which is our L naught, or the length measured in the reference frame, is equal to 250 meters, and we have here our velocity, which is equal to 0.75 the speed of light. So we are going to solve for the value of the L, or the length measured by the person outside the reference frame. So to find for the value of our L, we are going to use the formula for the length contraction, which is L is equal to the L naught times the square root of 1 minus V squared over C squared. So if we are going to substitute all the given to the equation, and we have L is equal to 250 meters times the square root of 1 minus 0.75 C squared over C squared. So we can cancel out the C squared. So we have L is equal to 250 meters times the square root of 1 minus 0.5625. So we have here 0.5625 because we squared the 0.75. And so we have L is equal to 250 meters times 0.66. So we have here 0.66 because it is the square root of 1 minus 0.5625. And so if we are going to multiply the 250 meters times 0.66, so we will have our value for our L, which is equal to 165 meters. So this means that the person on Earth will measure the length of the spacecraft as 165 meters, which is shorter compared to the length that is measured by the astronaut inside the spacecraft, which is 250 meters. So that's all for our problem number 1. So now let's move on to the problem number 2. So an observer on Earth measures the spaceship to be 300 meters and moving at 0.8 times the speed of light. What is the length of the spaceship for a crew member on board? So first, we are going to identify our given, which are, so we have here the value for our L, or the length measured by the observer on Earth, which is 300 meters. And we have here our velocity, which is 0.8 the speed of light. So we are going to look for the value of the L naught, which is the length that is measured by the person inside the reference frame, which is the crew member. So to find for the value of our L naught, we are going to use the formula for the length contraction, which is L is equal to L naught times the square root of 1 minus V squared over C squared. So if we are going to substitute all the given to our formula, and we will have 300 meters is equal to L naught times the square root of 1 minus V squared over C squared. So for us to have the value for our L naught, we are going to divide both sides by square root of 1 minus V squared over C squared. So we have here 300 meters divided by the square root of 1 minus 0.8, the speed of light squared over c squared, is equal to L naught. So we can cancel out this c squared. And so we have 300 meters divided by the square root of 1 minus 0.64 is equal to L naught. So we have here 0.64 because we squared this 0.8. And so we have here 300 meters divided by 0.6 is equal to our L naught. So we have here 0.6 because it is the value of the square root of 1 minus 0.64. So if we are going to divide 300 meters by 0.6, and we have the value for our L naught, which is 500 meters. So this means that the crew member on board will measure the spaceship to be 500 meters, which is longer compared to the measurement of the observer on Earth, which is 300 meters. So that's all for the two problems in the length contraction.